Hello, class. Today I want to talk about the term moles and Avogadro's number. I want to pick up where we left off last time. Since we didn't have class today, I'm going to I want to talk about the concepts that we would have covered today in class, so that we can stay um, hopefully catch up. I guess it's more hopefully catch up in the class. So we talked about this the last time. The atomic number is the number of protons. Let's see what's going on here. Number of protons. We said this was called the atomic mass, and it is not the atomic mass number. The mass number is always a whole number. The mass number is equal to the number of protons plus the number of neutrons in the nucleus. So it's always got to be a whole number. You either have one proton or you don't. You have one neutron or you don't. So that's what is wrong with this number. This is an average mass based on the relative abundance of each isotope of carbon that occurs in nature multiplied by its mass, each isotopic mass. We talked about Avogadro's number. This is going to be really important for the quiz. Avogadro's number is a quantity that we work with in chemistry because it's a quantity that we can see, that we can manipulate, that we can weigh on a balance, and so forth. All right, so the definition of a mole, let me erase the mass. Mass number. A definition of mole of atoms of any element has a mass in grams equal to the atomic mass of the element in AMU. So what they're saying here is that one atom of carbon-12, oops, weighs exactly 12.01 atomic mass units. We use the average if we don't know the particular isotope. If we have 1 mole of carbon, it weighs 12.01 grams. All right, so molar quantities, we get to measure the masses of those substances in grams. Individual atoms, we use atomic mass units. All right, so how are we going to use this relationship 1 mole of carbon equals 12.01 grams? Well, we use it like a conversion factor. We can divide both sides of this equality here by 1 mole of carbon, and we'll have a 12.01 grams over a mole. So if we need to convert from moles to grams, that's what we would use. If I have something in grams and I need to convert it to moles, I would divide both sides by 12.01 grams. This side becomes 1, and there's my true conversion factor. So if I have 36 grams of carbon, I would use this conversion factor to convert the grams into moles. All right. So yes, if we have 36 grams of carbon, 36 grams, we take this equality up here, divide both sides by 12.01 grams. This side becomes 1. That's important because it says that this conversion factor here is an identity. So if we have 7 times 1, our answer is 7. That's what we know in mathematics. So this conversion factor equals 1. And so we're not changing the quantity of carbon we have. All we're doing is changing the units from grams to moles. So when we calculate this out, the grams of carbon cancel out, and we get 3.00 moles of carbon. So this is a really important slide. This is the slide that shows you the algorithm, the way of calculating from grams to moles to molecules. All right. So to go from grams to moles to molecules, you'll have two conversion factors. You'll have the molar mass of the substance that you're working with, and then you'll use Avogadro's number, knowing that 1 mole of anything is equal to Avogadro's number 6.022 times 10 to the 23rd. That's how you'll convert from moles to molecules. And again, what is the importance of these calculations? Well, if A reacts with B to form C, then for every A substance, or let's say A is an atom, we have to have an atom of B for it to react to form C. So A can weigh 5 times more than B. That means to get the same number of atoms, we're going to have 5 times more mass of A than B. So it's about one atom reacting with another atom to make the product. And so because A and B may weigh different amounts or have different masses, we have to convert the grams to moles. And remember, moles is just a fancy term for it's a way of compartmentalizing a large number. Like we compartmentalize a dozen to mean 12, or we compartmentalize 12 and we say that's a dozen. We compartmentalize Avogadro's number 6.022 times 10 to the 23rd and say that's a mole. All right. So they're telling you here to remember that the link between grams and moles is molar mass. All right, these next slides are on global warming. This is why we want to learn the concepts of Chapter 3. We are going to apply what we found out about molecular geometries and molar mass and moles and atoms to describe global warming. So we know that CO2 contributes to global warming. We know the concentration of CO2 has been increasing over the past century. We saw that with the looking at the carbon dioxide trapped in ice. And the average temperature has increased over the past century. Now, what might be true is that the CO2 and other gases that are generated by human activity are responsible for the temperature change. The average global temperature will continue to rise as anthropogenic, which is people greenhouse gases increase the population. So we see a disappearing ice cap. This has major concerns. Probably the one that you see a lot of times in the news is the destruction of the habitat for polar bears. They have to go further distances to get seals, and the ice is getting thinner, so they can't perch out there and wait for a seal, and so the polar bears are starting to feel the effects of global warming. Also, we talk about the rise of the oceans, which will be gradual, but again can have major impact. All right, so here's a really strong visual. The snows of Kilimanjaro, there's been movies, and it's also been referenced in songs. But in Africa, here's Mount Kilimanjaro, and there's snow on it. And if we look at it, I guess, I don't remember what this picture was, but it's somewhere in probably 2000. You can see the snow was mostly gone. So in 2007, the IPCC stated in a report that scientific evidence for global warming was unequivocal, and that human activity is the main cause. The Kyoto Protocol, we see this so often. or every so often on the news, and that there's a lot of debate with this with the United States, because if we follow this protocol, it's believed that it could hurt our economy. Um, the big thing that we see out of this is trading emission credits allowed. So that is the driving force for large companies to maybe purchase or lease reserves of land, like in South America, to say we're using these trees to offset our carbon dioxide emission or greenhouse emissions. So we talk about taxing CO2 emissions or greenhouse emissions, and that's part of this protocol. All right. So here again, you see that the United States is the largest offender. And we have not signed it. Again, it really does come down to economy. If we sign something like this, then we're going to have to start moving away from more fossil fuels and less dependence on fossil fuels, which means coal, gasoline, and so forth. All right, that's the finish of chapter 3. You do need to take the quiz for chapter 3 by 11 p.m. on Thursday, I believe it is. And if you have any questions, just email me. And I will produce another PowerPoint presentation for chapter 4. Let's get started on it. All right, we'll talk to you later.